Okay, good afternoon everyone. We have started with our file system management, whereby we have covered up some aspect of files, okay, how they are organized, how they are accessed, and what sort of advantages are having for having one sort of a file systems vis-a-vis the other file system. Now, as we said, okay, once we got a files, they have to be stored somewhere, but we have to keep up the information about those sort of files at some place or the other. Let us say at one stage I may be having 1000 files. How do I know where exactly I have stored those files, when those files were updated, when you have added information to that, when you deleted information into that. So, all this information we keep in one another type of a file, which we call as a directories. So, this is what we are going to cover up in file system interfaces. Okay, what sort of a directory structures which we have got, and we have got another concept which we say is a file system mounting. Now, this maybe in most of the operating system, this is by default. The moment you have a device, automatically it gets mounted, but there are other operating systems where you have to mount the device. Maybe we will go through what exactly we mean by mounting a device, and then we comes the file sharing. Maybe you are working in a distributed environment, same file is being used by number of people, and at one stage I decide, okay, I have to delete this file. How about those 19 people who may be using those sort of files there? So, this is what we are going to discuss. Then what sort of protection we can have for our files? It may be, as we say, okay, it can be one physical protection. I do not allow anyone to come near to my system, that can be one protection. The moment it gets connected to some network or so, then that sort of protection I can provide. Maybe somebody is accessing my files through the network only, or I am in a network mode, or I am in a multi-user mode, maybe my file is being shared by somebody else. Then I have to think about how exactly my file should be shared, because at least I must be the owner of a file which is to be used by somebody else. So, how exactly we have to provide that sort of protection, we will discuss about in this session only.
Read only and all those.
Yes, all sort of privileges which we say, okay, I would like to make only in case let us say you have created a file, you say he can read, she can write, you can execute. So, this is what we call as the privileges which we give to a particular person for a particular files. So, this is for initially, as I said, okay, we have to talk about directory structure. Now, directory structure is a mechanism through which I keep the information about the files at some place. As somebody was asking FAT. So, this is related to these aspects only. Okay, you have got a directory system where which we keep at some places. Okay, initially all my information related to files is accessed through the directories only. So, my directory should be at some place which is accessible to most, because the access to a directory is mostly there. So, I must be having let us say 0 track, maybe 0 sector, having all your directory information there, all your FAT information there. So, this is what we have got. A directory structure is nothing but a collection of a node containing information about all files. Okay, all the files which are existing on my system, I have to keep the information about that particular files. Maybe I got this is my directory information, maybe this is some files, some information about files, and this is the actual file which is there. Now, what is the information which is kept in the directory, as we discussed in earlier sessions? Okay, it is let us say it is the name of the file which I have to keep, then who is the owner of this file, when it was last updated, or what sort of privileges are there for this particular file. All this information is kept in this particular file there. Maybe directory itself is a file, but it is a special type of a file which just have information about the names and all characteristics related to a file only. As such, it does not contain any data, it just contains the information about the files only, and both the directory structure and the files reside on the disk only. This is another characteristics. Okay, all your files, all your directory structure that reside on the hard disk only. Maybe I keep 0th sector for keeping information about the files. and we usually keep the backup of this sort of a system on some of the tapes or some of the CDs or some of any of the mechanism can be there. Now, what sort of information is kept on a directory? You just keep the name of the file which is there, then type what is the type of this particular file, whether it is a sequential file, random file, what sort of a file mechanism is there, or address, what sort of a starting from which address to which address this file has been stored. Because obviously on a hard disk, let us say on a first block, my file starts with the 20th block and goes up to the 30th block. That case, that is what is the address, and what is the current length, and what is the maximum length. Maybe this maximum length feature depends upon the operating system only. How does it allow a file to grow? Because in earlier system it used to be, I have to define initially, okay, this will be the size of my file maximum, and in case it goes beyond that particular size, maybe I have to rewrite that file after allocating more space over there. But now this concept has gone. Now what we do is, we just go by the maximum length which it can have, that is defined by my operating system. It can be indefinite length, some of the operating system allows indefinite length, or some of the operating system allows a particular length of the file which can be there. And then another is some historical information, date last accessed and date last updated. Okay, when was this file accessed and when was this updated, and the owner IDs. Obviously, who pays is, okay, who is paying for this space, because once we have to go for the accounting informations, we in case I am working on a system which I hired from someone, then somebody will be charging me for the amount of a data which I put it on the file only. So, my owner ID will give me this information, and maybe protection information, what sort of a protection information is the corresponding to this file. We will try to discuss all these things in this particular session only. Now, as I said, a file system is a data structure which we have got. Now, same way your directory is also one of the data structure which is there. Now, on this we can perform some of the operations there. I can search for a file, I can create a file, delete a file, list a directory, rename a file, traverse the file system there. The moment I search for a file, my search can be on the whole name of the file, or I just say star.doc, then what is this sort of a search? It is a group search. Yes, what I am trying to do is, I am trying to look into the files which are there in this particular system or particular hard disk, we are having this sort of names there, or create a file. Now, once I create a file, it will be always created in my home directory only, till the time I define the path. Okay, no, I do not want to create it in the home directory, I would like to create it in some other directory there, or delete a file, I can delete my own files there. As a administrator, I can delete any file, but as a user I can delete my only files there. Then you can just say a list a directory, you just go for, okay, I would like to see what are the files which are there on my hard disk, or what are the files which are there in my directory. I can say it is a list of directory, or it can be renaming. Okay, whatever file I have created, I would like to change its name, or traverse the file system. I would like to see all the files which are residing on my system, one by one I would like to see. So, these are some of the, this is what we call as the basic operations. These are the basic operations which I can perform on my file there, but I can combine these operations into some other operations there. As I said, in the files we can combine some of the operations. In this case also we can combine some of these operations to have a complex operations there. Now, how do I organize this? What is my criteria for organizing this? One is the efficiency. Okay, how quickly I can retrieve a file. Now, one way of organizing it, I put all the files on your hard disk without any organization. Then the moment I had to look for a file, I start with the first file and start looking for the file till the time I find that particular file. That can be one organization, directory organization, which can be there. I do not make any directory. I just simply say, okay, all the files I am putting it on my hard disk. The moment I require, I want to retrieve it, I will be retrieving it. It's just someone the way he organizes his folders. He says, I will create only one folder. Let me say he keep on creating the files. Ultimately, he create 10,000 files. Then one fine morning, he is looking for, okay, this is the document I am looking for. It's not here. Let me see this file. Let me this file. I think you might have seen this thing also. Okay, while you name your files, name your directory, in case you make a sensible names out of this, then retrieving information out of that is very easy. Or you imagine a scenario whereby you just name your file like 1.dat, 2.dat, 3.dat, 4.dat, ultimately you end up with 100.dat. Now you look for information. You will be looking for the information from all the files, or you are having very strong memory whereby you remember, okay, this is the file name which I have given for this. So, this is what we have got as far as your file structures are concerned, naming of the naming cultures are concerned. Maybe if I look at DOS, it allows me to give only 8 character names. Yes, I can think of some meaningful words through which I can find out the names, or you think of the Windows, maybe you give a very big names. What is the advantage of this? At least from the name only you can find out, okay, this is the content which will be there in this particular file. Same way is true in directory also. I can think of a bigger directory names or a folder names. Folder is another thing which we say the directories only. Now, that is what we have got. We have to think about how efficiently I can locate a file there, and naming, as I said, it is convenient to users. Now, in case two user can have the same name for the different files, I got one file, I keep the program as quadratic.c. There is another fellow there who is also writing quadratic equation program only, he also write quadratic.c. How does this sort of thing work in case I had dumped everything on the same system only? So, we have to think about this, or the same file can have a different names. Let us say there is one file, I put one name for the same file, another fellow puts a different name for the same file there, or you group of files based on the properties which are there. Let us say how do you organize your folders? Okay, I say, okay, these are my Word files, I write Word, these are my program file, I write program folder, these are my some other file, I write some other name for this. So, this is what we call as a grouping. As I say, I put all Java programs at one place, all games at another place, like this I can put the files like this. So, this is how we can organize our directories. Now, how do I organize my directory system? We have got a single level directory. What we have got in a single level directory is all users at the same level only. Maybe this is the directory I look for, maybe cat, BOA, test, data, mail, and all these directories are there, and in that particular directory there are some files. My directory cat can have 100 files, or my BO directory can have 10 files, A can have another 5 files. Maybe this leads us to some sort of a naming problem or a grouping problem. I can't group in this particular scenario. One, as I said, in case there is no directories I make, I simply dump all the files at one time. Let us say I create one file, another fellow comes, he creates the same similar name file, then obviously these sort of files cannot survive for a very long time, and accessing in this particular case is very difficult. So, that is why one thinks of a single directory for all users. We have got a naming problem and we have got a grouping problem in this sort of a scenarios there. Then one thinks of a 2 level directories, that is what we do is we think about a separate directory for each of the users. I say this is my user 1, user 2, user 3, user 4, these are the directories. under user 1 I can create number of user file or directories there. Maybe then in that particular case one user, two users can have the same file name, that is one student of one class, another student of another class can have the same file name, but still their program will be residing in the different directories there. Right. Let us say user 1 he creates a.c, user 2 also create a.c. So, they can survive, whereas in case I try to have this sort of survival in my earlier directory system, whereby every file is coming at the same place, this sort of a survival is not possible. Now, as I said, can have the same file name for different users and it is efficient for the searching purposes. Let us say as a user I know I am the creator of this file, I will be looking for in my directory only. I will not go to somebody else directory and look for the file. Maybe in this particular case again there is no grouping capability still, because it is a single level directory structure, a 2 level directory structures which are there. Now, then how do I access? I access it through a path. I start from here, go up to this place and then access the data there. Now, then next we have got a tree structure directories. That is what we have got is, we have got a structure whereby each of this directory, just like we got a 2 level of directories, I can have a multiple level of directories, but very clear distinction between who is the father, who is the son. Maybe this is the root directory, this is the next level of the directories and this is the further level of the directories there. Now, each of these directories can have either files or subdirectories, files, groups, everything can be made in this particular scenario only. So, this is what we call a subdirectory and the concept of the directories. Now, how do we access information in this particular case? The moment I had to find out information in spell, I go to this, then from here I go over here, then from here I go over here. If I have got, let us say I wanted to look for the file name all. Maybe this sort of tree structure directory is cause efficient searching, because I may be organizing my file in a way. Let us say as a user I can think about making my file in one directory, then in that directory I further make some further directories and from there I make some further directories there. And all the time I will be working my current directories, it has got a grouping capability, I can group my files into one group. Now, as far as accessing of this directories is concerned, we have got 2 methods through which we can do it. One we say is absolute paths, second we say is a relative path. Now, what do we mean by this absolute path and relative path is, okay, let us say if I am there at this particular directory, this is my directory A, further I have made 2-3 directories B, C and D, then further I have made E, F, let us say G, H. Let us say these are some of the directories which I have made. Now, okay, there is a file here, let us say x dot dat. I wanted to access this x dot dat file. My absolute path can be, if I start from here, go to D, go to F and then I access this sort of a x dot dat. That is what we call as the absolute path. Starting from one end, I go up to this particular path. This is what is a absolute path. Even if I am here, let us say I am here, then what will I do in this particular scenario also? I will go back and then I will be accessing this sort of a path. This is what we call as a absolute path It's just like we say c slash x slash a dot dat, right. That can be one sort of a path which we can define over there. Or another path is, let us say I am here, why should I go back and then access this sort of a file? Maybe if I am here, I will be accessing through this path only. So, that path we call as a relative path. Okay, just like from this particular directory only, I am accessing the next level of the directories. So, this is what we have got as a relative path, and this is what we have got as a absolute path. I hope this is clear.
That is for relative case, you are not going to the root.
You are not going to the root, from there only you go. Let us say you just say cd xx, then I can define my path from here only, right. Okay, I am not going back to my previous root directory, and from there I am having the path there.
Relative paths must be having some limitations, so that they can go to the lower levels only. But in the absolute path, we can go to the other branches of the root.
A relative path is always valid, okay, in case I had to go on this direction, downward, or in case I have got a parallel, only then I can go. Let us say I am here, I want to go here. Let us say I come back to this and then go back to this.
We have to come back first.
Yes, obviously, in case that depends on the path, okay, what sort of path I am choosing to go from one place to the other there. So, this is what we have got, a absolute path and the relative path. Then comes various operations I can perform on this sort of files. Okay, it can be, as I said, it can be absolute or a relative path name, and all sort of a operation which we performed, that is performed on the current directory only. Okay, creating a new file is done in the current directory only till the time I define path there. Let us say I am here, the moment I say okay, I would like to create a file here, then file all the time will be created here only. I can't think of if I am here creating the file over here, that is the difference. Or we have to, let us say we have to delete a file. What is the operation in this particular case? First of all, I had to come to the current directory, whatever is my current directory, first of all I must come there, and then I can apply the remove files. Then another thing comes, okay, let us say I wanted to delete a file, I am here, let us say I would like to delete D. How about this? What happened to these files? No, that depends upon the operating system. What sort of operating system I have got? Okay, some of the operating systems, they, in case it is not empty, they do not allow you to delete. Yes, he is right in saying DOS does not allow you to delete till the time you force yourself to be deleted, but some of the operating system they allows you to they take it by default. The moment I want to delete this, automatically this whole thing will be deleted. So, that is what we have got as a remove file name. Or in case I would like to create a new directory, then what I have to do is, if I wanted to create a new directory here, first of all I must come here and then apply the command of a make directory. That is, first of all I must be there in the current directory, only then I can think about creating this sort of a directory there. Just like this thing, if I am in this current directory slash mail, the moment I say make count, in mail itself make a count directory over here. And as I said, deleting mail, let us say I want to delete this mail, then obviously what I am interested is I would like to delete all this files over here. So, this is my interest which my operating system has to allow me to do. There are two ways. One is I just go to mail, delete all this first, then come to the deleting of a mail as we used to do in a DOS, or my operating system can straight away allow me to remove this mail and automatically internal files will be removed over there. Maybe in some of the operating system it shows, the moment you say mail is deleted, it shows you program is getting deleted, copy is getting deleted, PRT is deleted, EXP is deleted and count is getting deleted over there. So, these are some of the operations which are possible in case of a tree structure directories. Now, another option which is available to us is in a 2 level directories or a tree structure directories, in case I have got a file, it is I who can operate upon that particular file only. Maybe your logins are like this. I hope some of you might have created your own logins in case of a Linux or a Unix or a Windows also. Okay, the moment you create your own logins, you go to your particular directory there. Let us say I create my login here. Let us say okay, in case my system it creates a logins, my program is my login, then I am the owner of this login and whatever file has been created in program, it is my programs only, user slash program, or in case it is my directory name is RAM, user slash RAM. So, whatever program has been created, that is there in the with the login name RAM. Now, Shyam cannot get into the RAM program and delete them. That is what we say, we have to create logins through which we have to access this sort of information there. Now, another type of a directory is we call them as acyclic graph directories. Now, in case of a tree directories, we are very sure okay, what sort of a structure we have got, but in case of a acyclic graph directories, what we have got is we can just link up 2 directories. Okay, 2 directories can be linked up. It is not a very clear cut father and a child relationship or a branch and a leaf relationship. What we have got is any sort of a linkages can be built up into this sort of a things. Question arises, why do I want to have this acyclic graph directories? Yes, so basically for the sharing purposes. You imagine there is one file there which is to be used by 10 users. One option can be you copy this file in all the directories of 10 people. Now, question arises, if somebody updates it, you created a file in all the 10 directories, in case one of the fellow updates, does it getting reflected in all the other 9? No. So, what we do? We just do not copy this particular file, but we link this particular file with all the other directories. I hope some of you might have tried this link command of Unix. Maybe you, those of you can try here. Link is in case I would like to give a link of this particular file to some other user. Then in that case what happens is with this particular link, in case of a Unix directory system, there is one link field there. It will show you, in case there are 2 people who have got linked to the same file, it will show you 2 links, it will show you 3 links. That means there are 3 people who have got linked to the same file. Now, in this particular case, in case one person updates, then obviously this updation is available to all the 9 other users there. So, that is the uses of this acyclic graph directories. Maybe Unix allows you to do it. Okay, what you can do is, okay, once you would like to link up some of the files, some of the directory with the other file systems there, you can just go for the link there.
And less memory space is also there.
Obviously, because once it is only a link which we are creating, then obviously other file, other data is not copied. It is only one link which has been built up there, just like this. Okay, maybe this particular file is there, there are 2 links which has been involved over there. So, this is what we call as a acyclic graph directories there. Advantages are okay, you can just link up number one file with the number of users there, and your updations are, there is no problem with the updation as far as the integrity of the files is concerned. Then question arises, in case I have linked it up, this particular file is linked to 2 users, and one of the users tries to delete this particular file. One, it can lead you to the dangling pointers.
So link will be deleted.
No, let us say I as a user have deleted my link, but I can't delete others link, right.
File will not be deleted.
So, till the go there is always a possibility कि in case this file has to be deleted, then you have to seek permission from all the others. It will ask whether this file has to be deleted or not. Till the time everyone says you delete it, it will not never get deleted there, or you just unlink. Okay, I as a user I unlink this particular file from my link, and it automatically then it is a single link, another fellow can delete this particular file. So, this is what we call as a linking. Now, maybe tree structured directories is a subset of this particular directories, as we say trees are a special case of a graph, same way tree directories are a special case of a graph directories there. So, this is what we call as a have a shared subdirectories and the files. Not only we can share a file, we can share a directory also in this particular case. So, it can have a 2 different name, maybe you can think of aliasing also, same file contents can have the different file names, or if directory deletes list, then dangling pointer problems can be there. There can be as I discussed, there can be dangling pointers. So, it can be solution is back pointer. So, we can delete all pointers, or you can think about a daisy chain organization, or you go for an entry hold count solution. Entry hold count solution is how many people have been linked up to this particular file, and based on that only you delete this sort of information there. So, this is a journal graph directory which is there. Now, only thing in case of a acyclic graph directory is we have to see there is no cycle which is formed there. There is no looping in between, only linkages are there, but no looping is there. So, this is journal graph directories which are there. You have got all sort of linkages which we can define to a particular file there. Now, in case of a graph directory, how do we guarantee there is no cycle? Solution is we allow only links to the file and not to the subdirectories. I can link up a file, but not the subdirectory to the root directory. Now, every time a new link is added, we use a cycle detection algorithm. We will not talk about the cycle detection algorithm, that is a graph theory only. We have to determine whether this is okay or not. What do we mean? The moment I try to add a link, first of all I must make sure this does not lead me to the cycle there. Now, this was about the directory system which is there. A directory is there, whereby all sort of access mechanisms related to a file are through the directory only. Now, another is we wanted to mount a file systems. What is a file mount system? A file system must be mounted before it can be accessed. The moment I wanted to access it, it must be mounted. Just like you got a C, D and E partitions. In case of a Windows or a DOS, automatically it gets mounted. The moment you switch on the system, your C mounting, D mounting is there. But whereas in case of a Unix, what happens is whatever device I have got, first of all I must mount. What does a mounting means? I am linking my file system with the system there, logically I am connecting it, so that there is some name given to this particular file system, and I can access all my files through that particular file system. Just like in case of Windows, we have got a C as a name for the file system, D as a name, logical name for the file system. Same way we have to define some names for the file system which is available to me in case of a Unix systems, and we call that as the mount point. Mount point is a point through which I mount a particular file system, just like C, D are the names which have been given. Same way we have got a mount point in case of a systems there. So, this is how my things look like. Let us say I mount it here, then obviously everything what is available to me gets mounted there. But in case I mount at this particular point, then only this particular thing is available to me, not this particular thing, right. Okay, whatever is there in this particular tree, that will be available to you once you mount, otherwise rest of the things will not be available to you once you mount any of the systems there. So, this is how my mount points will look like. Let us say this is my mount point, then this thing is available, but not this thing is available to me. Now, then we come to the file sharing. Now, file sharing is in case I would like to share a file on a multi user, maybe sharing a file is not possible in a single user system, it has to be a multi user system, only then I can share some of this particular file. Now, maybe sharing may be done through a protection schemes. You imagine a scenario, you are sharing a file and that sharing is in the write mode. I update the file, somebody else comes, he updates the file, somebody else comes, he updates the file. What is the end result of the file? There is inconsistency in the data there. Maybe I can think about sharing a file in case I am going for the reading only, right, not in the write. What happens in case of a reading there? Okay, let us say I have got a word processing software which is available to me. The moment I share, the moment I say okay, I will be sharing, then there may be some linkages which has been defined to this. Now, how do we do in case of a memory management? No, in case of a memory management, what we do is, in case I have loaded my Word software in one of the partitions there, while I am making my logical address space for my program, I will be giving that sort of address to this. Maybe I explained it in my earlier lectures. This is my memory which is there. Let us say this is the partition where let us say my Word has been loaded. Let us say starting from address x to x plus 100, right. Then let us say this is my data area for the program A, this is data area for the program B. Let us say this is y plus 10, then this is z and this is z plus 10. Let us say this is the memory which I got. Now, the moment I make a some sort of a page map table for these jobs, what I do is I just define my page. Let us say this is my page map table for the job A, this is for B. So, what will it have? It will have addresses x up to x plus 100 and then y and y plus 10, right. So, this is what is my address logical address space for this particular job A. Same way, the moment I define logical address for B, I will be defining x and up to x plus 100 and then z plus 10. So, this is how my space is getting shared, that is two jobs. Once it makes a page map table, it will be having this information here as well as this information here which is common to both. Now, I have loaded Word at this particular addresses only, but it is getting shared and it is being put at two different places over there. So, this is what we call as a file sharing. Now, in case of a distributed system, maybe I will be sharing this file across a network. Okay, I got a whole network my one file can reside at one place or the other place is there, and it can be shared from those sort of things. And we say this network file system is a common distributed file system, file sharing method over there. Okay, this is one scenario, network file system, whereby I can be my files can be there at a different places. Let us say I am sitting over here, but my Word software is on somebody else system. How do I have this sort of A and B or a mapping in this particular case? That is another important concept which we usually study in case of a distributed operating system. Now, then comes another important aspect of this protection. Okay, how exactly I can protect my files there? Now, maybe your file owner or the creator, he is the one who is to protect his files. Now, we should be able to do what can be done by whom. Now, before we discuss about the protection, we have to think about what sort of accesses are there in case of a file there. It can be read. I may be reading a file, because sharing is done with the help of this sort of protection, or I can write, maybe I can write some information into a file, or I can execute, that is whatever file is there I should be able to execute this sort of a file there, or I can append, I can add something to the file there, or I can delete, or I can list that particular file. So, these are some of the operations, some of the types of accesses which I perform on my file. Now, if I am just reading a file, I may allow anyone to read that particular file, or if it is a confidential data, I may not allow anyone to read it, because this is how linkages are defined. Or I am writing, I may allow everyone to write into that particular file, or I may not allow anyone to write into that particular file, or execute, or append, or delete, or list. So, I have to define some of the privileges who should be able to do what on a file. Maybe as an owner I can do lot of things. As an owner I can read, I can write, I can execute, I can do everything on of my file, but why should I allow you to do write it in my file or read from my file there? Now, that is why we what we do is we just make a access list for this sort of a files. What is access list? Okay, access list is okay, in case I got a file, I got a file with me, and there are number of users for that particular file which can be there. I just define a list. Okay, user 1 he can execute, user B he can read, user 3 he can write, user 4 he can do this way. That is, for every user I make a access list. Obviously, that is a very good example, but you imagine there are 1000 users, for every file has been created, you make a list of 1000 entries, whereby you define for each what is the privilege defined for each one of them. That usually is not possible, because I can't think of for every file created, I must think about who will be you doing what with this sort of a file here. I have to think of some mechanism through which I can define in a better way, because obviously in that case it will become a variable list also. Okay, there will be a long list of the privileges which I am defined for all the users which are available to me. So, what we do is we just go by the groups, and we go by the mode of access, it is a read, write or execute. So, these may be the some of the accesses which can be there. I make access privileges there for every user or every file which is created. We just say owners access, group access and the public access. Let us say you imagine a class, you are a class of a person who are in the modular ME. Let us say there are 20 students who are there. He creates a file, then he becomes a owner for that particular file. Now, then he has 20 people in his modular ME group, that becomes a group. Now, there is another ME program which is going, that is a public or some other people who are there. Now, he can define, okay, as a user I can allow my file, as a owner I should be able to get all sort of accesses for this particular file. For my own group, they should be able to read and execute, and for the others who are from the other ME group, they should be only able to execute it. So, what are the privileges I define? So, what I am trying to do is, for the owner we are defining all, for group we say read and write, and for others execute. So, this is what we say it is a privilege list which I define for each of the users there, right. Okay, this is the way I define a privilege list. Okay, these are some of the privileges which we have defined for each of the group of the people there. Now, this is in general what we do. Okay, we attach a group to a file, and these sort of privileges can be changed, or I can add few more privileges into the same file there. Whereas, in case of a Unix, what they have done is, for each one of them they have defined 3 parameters. Let us say what they say is it is a read, write or execute. Either I can read or I can write or I can execute, and each one of them is a 1 bit. Now, each of them read, write and execute is a 1 bit data which can have the value 0 or 1. 0 you are not allowed, or 1 you are allowed. If it is a 0, it is a not allowed. If it is a 1, it is allowed. Now, what we do is we make a group of 3 for each of the users. Once I have to define my access list in case of a Unix, what I do is I just say owner, then group and others, right. Now, each one of the file it has got 3 bits, right. So, each of these files has got 3 bit information, and the moment I want owner, he should be able to read, write and execute, and the moment a group is there, I say he can just read, write and does not execute, and as a others I just say he can read, can't write, can't execute. So, this becomes a access list for one file. Let us say my file name is a.out, and this has got this sort of a access is there. I hope you might have seen in case of a Unix, you find a one sort of a string attached to each of the file, where this sort of a things has been written. Okay, either it is a dash or RW, something of this order is there, that is only this sort of a string which is there, and some of the operating system they convert this sort of a thing into binaries, oh sorry, base 10, and this comes out to be 7, 6 and 4. So, that is corresponding to the file a dot out, we have got access 764, that is my a dot out has got 764 as the access matrix, access privileges which are attached to this particular file there.
So is it in decimal or hexadecimal?
No, this is like this only, decimals, not in hexas. So, at the moment I wanted to change mode of a file, let us say I wanted to give him access for the execute also, I want to read and execute, it becomes 101, it becomes 5. So, I will say change mode a dot out as 765. So, what I have done in this particular case, I change the access mechanism of this particular file to 765 over here. So, this is how my access mechanisms work in case of files there. So, that is what we have got. We have got your mode of access as read, write and execute, and we define 3 classes of user, as I said, it is a owner, group or a public access. Now, for each one of them we have got this sort of privileges, and we can just say change group to this, and let us say this is group privileges which has been defined as 760. I can just say change mode 761 to the game, that is I am trying to change the privileges of this particular file from the existing ones to the new ones there. So, this is what we have got as a directory structure. Okay, we have got a directory structure. Idea of a directory structure is to organize your files in such a way, so that it gives you a better access mechanism for your files. As I said initially, I said okay, your directory structure maybe all the files you put it at the same place, but this has got a problems. Okay, once you put every file at the same place, some of the files which are there may be having a duplicate names. So, that sort of files I can create. What we do is we try to create another level of the structure there, which we say is a 2 level directories. Okay, for each of the users I create a directory. The moment he has to go to his directory, he logins into his directory and gets to only his file which he has created. He is not concerned about what are the files the other user has created over there. That is one another type of directory, or another type of directory which we talked about is a tree directory, whereby all the it can have a number of levels of the directories. Maybe it is the implementation issues which are there, whether it can be 3 level, 4 level or 5 level, but theoretically speaking there can be any level number of levels for the tree there. What is the facility which we have got? I can think of grouping my files. I can think of a Pascal file at one place, Lisp program at other. In Pascal, first year program at one place, second year program at the other place. So, this gives me grouping facilities, right. Now, once we have got this sort of facilities, my access mechanism very fast, other things they also become very organized in this sort of a scenario there. Now, but this also suffered due to this, in case same file has to be used by number of users, then I have to copy the same file in number of directories there. So, this leads to me the other problem which can be solved with the acyclic graphs. What we do is we just link one of the directories with a number of links there without copying the actual contents there. Advantage is that in case somebody updates it, everybody gets the updated version. Now, then we discuss about the file system mounting. Okay, it has to be linked to the logical space once we wanted to access any of the medias there. That is what we have got file system mounting. Some system by default does it, some system has to do it explicitly. Then we discuss about the file sharing, how exactly a same file can be shared by a number of users there that is what we have discussed. Then we have discussed about the various protection mechanisms. Okay, you define access list, but it is very difficult to operate upon access list. What we do is we just define our file privileges as group or a group, others or the owners. So, that is what we can think about the protection for a file. There are other protections also. Okay, I can give a password to a file. Okay, the moment I create a file, I just define it as with a password. The moment I give a password to a file, nobody can access this particular file till the time he has got a password there. Or another option is you can make a file hidden. You change the properties of the file and make it as a hidden file. Then nobody will, the moment it is listed out, nobody will be able to list that file, right. Maybe in case of a DOS, what we do is we just, once we have to define a file name, I define dot before the file name. So, in that particular case what happens is that file remains as a hidden file. Or in case of a Windows and other things, what we do is we just define okay, this is some sort of a properties which I can change in that particular file, and then obviously those properties will be changed for that particular file there. So, this is what we have to discuss in this session. We will complete in next session we will talk about other things. Thank you.